Have you seen Conrad's Trap minivans?
What's that?
Conrad's Trap.
Oh man, I want to see it.
Dude, you should turn your minivan into a trap minivan.
Well, his brother Rayner's like redoing like an old bus from like an airport thing. Yeah, it's really cool. Okay, all right, folks, put your Chromebooks away. Let's talk about some stuff. Um, eh, um, and here we go. So yesterday we left off, and I just want to give you just a little bit of review before we watch the rest of this clip. So we're talking about chapter 2. Hopefully you got all your questions in. It's great. I know I'm giving some people some grace period because of some questions and stuff like that. We will talk tomorrow. So I'm going to try to grade those today. And tomorrow we'll talk a little bit about the abstracts. So when I grade these, I will give you it'll be out of 30. Okay. And I will put little messages on there that says like, hey, I like this, or no, this isn't a journal, that sort of stuff. Okay. You can always send me private comments on that too. That's fine, or whatevs. Okay. But then I will return all of those back to you. Okay. And go from there. Yes.
You know why mine's like.
Yeah. We talk.
Just wanted to double check. I know sometimes
Yes.
you forget.
Okay. I am in here during SRT. Okay. Now listen. I'm going to cut everybody some slack on this first one, okay? All right, because it's your first one, okay? But make sure if you have questions, okay, that you hit me up either the day before, not the day of, right? Yeah. No, but I was up at 11. You could text. You could always try, okay? And that's fine. I think I went to bed at like 11:15 last. Okay, that's great. But send me an email. Okay, and then that way you can be like, hey, I need help on this one, or chat me up. Everybody kind of gets. I'm gonna give you some grace on this one. It is the first one, okay? But yeah, try to do that before, or hit me up, at night. I was trying to figure out crap things. So I did figure it out, by the way. Yeah, it was. So I had issues, and Maggie, this is for you too. If ever you're gone, I will try my best to remember. This is the only class I have trouble recording, but you've seen them every day. Okay, there should be a recording from every class every day. If you don't see one, either A, I screwed up, or something's wrong with YouTube. Because in anatomy, we were having trouble with the feed. I had to reset how you see it on there, so it's in like a sequential. So they were all there. It just didn't look like they were all there. Yes.
Mr. B, can I get a Band-Aid? I picked a scab.
Yes, you can.
Thanks, Mr. B.
You're welcome. So that's the homework stuff. Okay. I'll try to grade those throughout the day today. I will send you those messages. I will return those, so you'll know okay, I need to do something different about my journal, that sort of stuff.
Thank you.
You're welcome. Okay. So yesterday we're watching One Strange Rock. Okay. Here's a little quick review. Okay. We saw some people in Africa that were mining salt, not really mining, just getting salt. All of a sudden this dust storm comes up. The guys in the space station see the dust flying across Africa and then over the ocean and then hitting South America. And then that dust fertilizes the plants, and the plants grow, and then the plants suck up water, and then that water goes out of the leaf, and then it goes up into the air through evaporation, and it turns into this giant river, the largest river on Earth. And there's a nice lady that climbed a tower. She's measuring that river. Then that river flows into the Andes. When it hits the Andes, that water precipitates out, causes the water causes the mountain to erode. When that erosion happens, everything goes down back into the ocean, but now carrying nutrients with it. Those nutrients are very important to feed things, and we learned about something called a diatom. We know that if we take 2 breaths, 1, 2, that one of those breaths, that oxygen was provided by the diatoms thanks to a wonderful process called photosynthesis. And that's where we left off. These are all diatoms from the International Space Station. Yes.
Okay, I have a question. So,
Yes.
like, the leaves, like expelled water, or whatever.
Yeah.
So is that what dew is, or is dew like?
Yeah, great. That's more of like a condensation kind of thing. Like, like how your glass, if you have like a glass outside, you get that condensation. Yes. So that's not water like coming out necessarily from the plant. But I've been peed on by a plant before. Like no joke. I remember it. I was coaching cross country. We were stretching underneath the tree at Warville Park, and well, it could have been a bird, but I saw no bird, and there was no, like, I looked at it. I think I may have even tasted it, but like, yeah, the water comes out of leaves, and a lot of times you just don't see it, or it evaporates out. But this was a nice drop of water. Okay, because so trees have real quickly. So when we're talking about adhesion, cohesion, if I am, well, you guys have all done this before, right? Where you've taken a straw and you put the top of your finger over the straw and you can pull up the liquid, right? So that liquid sticks to the sides of the straw, and then the water sticks to itself too. So when we water a plant, that water then goes into the roots, and that root, okay, begins to send it up through the plant, and it's sticking to the sides, just like they showed you in that video yesterday, how it went out. And it eventually has to go. Some of the plant is going to use it. Okay. What happens if you don't water a plant? It dies, but like, what's it look like before it dies? It starts to wilt, right? I always know I'm not a great plant person, but I have still kept alive that lemon tree, and I've also kept alive a couple other plants. But sometimes, like, I have this plant, I can't even remember what it's called. My mom used to call it the monkey Peter plant, which is weird, but anyway, so it starts to kind of like droop, and I was like, oh crap, better water. Yes.
Oh, so like trees put like oxygen into air, right?
Yeah.
So when the water goes up into the tree, does it like how do I say, like, not put water into air, but like put, you get what I'm trying to say?
Yeah. These are all great questions, and this is I mean, this is not even off topic. Real quick, let me show you this. This should look somewhat familiar. C6H12O6. What's that? What's that? Come on. Glucose, I heard some say. Glucose, right? Okay, glucose, okay, like food, right? Why do we eat food? Boom. Okay, yeah, there we go. So glucose, okay, we breathe in oxygen, right? Gives us, okay, what do we release? We release CO2, okay? We also release water, H2O, and plus energy. That's how I spell energy, NRG, okay? Now, what's the name of that process? Glycolysis is part of it. Citric acid cycle, Krebs cycle, electron transport chain is all part of, here's a hint, cellular respiration. Okay, now, these are the reactants, these are the products. If I switch this arrow, okay, what's something that takes in energy from the sun, takes in water, takes carbon dioxide, but gives us oxygen and food? That's plants. That's the yeah, it's just the reverse, right? Okay. And they don't do that with, just any old organelle. They have a specialized organelle. What's the name of the organelle in plants that do that? Chloroplast, right? CHLORO. Yes, remember the song? No? You guys remember this song, man, from Bio One? It was ridiculous. I'll play it later. It'll take me a while. You remember it, right? I mean, I played it like I made you yell plast like every other day. Okay, and then remember I yelled at you a lot for this. How many carbons are in glucose? 6 carbons, right? How many carbons are in pyruvate? 3 carbons. Kind of Army Day stuff. Is this ringing a bell at all?
You still do that?
I still do it. Okay.
I never have to do that.
Never. Oh man, it's fun.
When is the next day?
I don't know. It's not till like the November. Like it's close to there. I'll let you know if you want to participate. What's that? What? Yeah, sure. Okay, so Emma, that was a long answer to your question. So plants take in this
I was just
stuff.
looking for a yes or no.
Does that make sense though?
Oh,
So they're taking in water, right?
right.
And then they're using that water to make oxygen. Okay.
That
So
makes sense.
oxygen is a product of photosynthesis,
Okay.
right?
See,
Okay.
you had to just break it down so my mind could understand it.
Yeah. But of course, just like everything else, like when we eat food, we don't use everything. We got some leftovers, like I urinate, I defecate, right? And so some of that water goes through the plant because in the plant, every plant's got these little cool things called stomata, and they open and they close, and when they need to get rid of some water, they open, the water comes out. It's like the plant's little pee hole, right? Yeah.
Did you know that in the morning when you first pee, your pee has so many good nutrients in it that your body did not digest?
I drink my pee every morning for that very reason.
I really hope you're joking. They said it makes a good face wash. I wonder if they put people's pee in face washes.
I use it for a face wash too.
Really? You use it as mouthwash too? Because
It's
that's what
just-
the ancient Romans
I
used
do
to do.
all of it.
Me too. I thought I was the only one. It's true.
All right.
They do.
So let's look at the diatoms real quick.
Can you have one as a pet?
A diatom as a pet?
Yeah.
They're so tiny, they're
Yeah, you could just have,
microscopic.
like, one of them.
Hey, I will see if I can get. It might be fun to have like a class set of diatoms.
Yeah.
Have you ever?
Oh, freak! I love this, huh? No one's ever asked me this.
How do you know?
Oh, hey. I will buy some. Hey, and so also I'm gonna need some soybeans sometime soon, like the whole soybean plant. You got me? Okay,
We all
but
can
not
get you.
yet. We,
We all
like
connect to farm.
we're still like a month away from harvest, right?
Well, it depends on if we get rain or not.
Yeah, no crap. Okay, maybe we might get
Pull one
super.
out and like put it in a pot.
Yeah.
This might not be important, but
Yeah.
I saw a tomato field the other day.
Cool.
I was amazed.
Yeah. All right, here we go. So here's the diatoms.
Oh, yeah.
Looking at the oceans from space, sometimes you see a local area that's an entirely different color.
This guy somehow like brings me peace.
Amazingly enough, what you're looking at is microscopic life. Diatom blooms that reflect the light differently so that they show up from space.
Biggest one I think I ever saw was huge. It covered hundreds of miles.
You know, when you swim in the ocean, you don't notice the diatoms around you. But when you're in space, you see the vibrant colors, life.
It's just so stunning, the blues and the greens, but also like, wow, those things are keeping us alive.
There they are. Okay, so fast for a little bit here. Okay,
Have you
here
ever
we
watched
go.
the movie Nim's Island?
Nim's Island.
Love
No.
They have, do you see like the glowing stars? I just thought of that.
Oh, tell me more.
Watch it.
It's
And
good.
sometimes these glaciers move really fast, dumping tons and tons of nutrients into the sea.
Jeez.
Boom! Sparking a feeding frenzy and a population explosion. But then, just as quickly as it started, dinner time is over. The glaciers come to a grinding halt and lie dormant sometimes for decades. Boom becomes bust.
When the nutrients run out, the blooms fade and most of the diatoms die. Their carcasses slowly fall to the ocean floor, where they carpet it in a layer half a mile thick. We call it marine snow, and that's exactly what it looks like. Snowflakes. But unlike snowflakes, they never melt. And over millions of years, the seabeds rise, the ocean levels fall, and the ocean floor becomes a salty desert. The desert that blows all the way to the Amazon, that was once a seabed. And the dust that makes the rainforest grow, diatom shells.
Are you getting this? Does that not just gives me chills when I just like look at that? I'm like, oh my God. Right? The dead diatoms were the salty seabed that turned into dust, that fed the plants, that caused the plants to move, that caused the plants to send the water up into the atmosphere. That water then went into the mountains that caused it runoff to feed the diatoms, also that the diatoms would live and then die and the cycle would start all over again. I just broke that. I don't even know how I did that. That's amazing. All right. What? Right? So cool. So, right? Are you with me on this? Okay, good. I hope you are because my mind is blown.
It doesn't take much to blow your mind.
Well, that's true. I haven't showed this. I showed this to my kids and they liked it. And my two boys. And last night, and it was cute because I said to Ira, I go, I showed my AP class one strange rock. And he's like, everybody should see that. It's very important. So cute. Okay, let's go. Let's take just a couple bit of notes here, not much. Okay, and so that was a long, what seemed like a diversion, but we covered a lot of stuff. Thanks to this one slide, we talked about capillary action and surface tension. Okay. All right.
Watching in silent with your kids though, because it has those in it.
What, they have diatoms in it?
Like her father.
What?
goes
Say
out
it
and, like,
again.
looks for it.
Nim's Island.
Yeah.
Is it a cartoon?
No, but it's like a kids movie.
Man, would my kids like it? You think?
I think so.
Is it on like is it on a Hulu or Netflix or
I don't know.
Disney
I just
Plus
love the
or
disc.
something?
It's like an older movie.
Okay.
But it's really good.
Okay. If I can't find it, can I borrow the DVD? I haven't played a DVD in probably 2 years.
I know.
That'd be cool though. All right. So remember on Monday, we went out and we started my car and we filled up balloons and we looked at the differences between the CO2 concentrations of the gas that we were collecting. And so hopefully these are terms that you knew before. Acid, okay? It's all about the hydrogen ions though, okay? That's the key with the hydrogen ions. I like to draw this as well in my little notes. Okay, when I talk about pH, the big number is 14, right? And then there's 7, and then there's 0. Okay, these are my from here to here, right? This is the acids. Okay, from here to here, this is the bases. Okay, but with this, okay, as we increase the hydrogen ions, we put H plus here. I'm going to draw an arrow down. Okay, H plus arrow down. Okay, and I'll show you this in a second, Max. Okay, and this one is hydroxide, so that's OH negative. Please know those chemical symbols. There's going to be several chemical symbols that we need to know throughout our time together. So this is what we've got here. I'll leave that there for just a second. So hydroxide, OH negative, hydrogen, H positive. Okay. And we just add hydroxide ions, we become more basic. But remember, anytime we're going from here to here, it's going to be acidic. It's becoming more acidic. So even though the ocean, we'll talk a lot about the ocean and how the ocean is becoming more acidic, but it's still basic, right? It's still basic. If it was really acidic, it would be, I mean, like acid, then we'd be in trouble. Okay?
Hold on.
Yeah. Come on, baby. This is what happens when I move this. There we go. All right, so here's just some examples, of course, like bleach, basics, sodium hydroxide, seawater, okay, pure water, of course, distilled water. Okay, normal rainwater is acidic. It's a little bit acidic. One bum thing about this class this year is that in the summertime, I would have made you do two things. We would have gone to the prairie that's located at the Church of the Brethren. Okay, and then we would have also gone to the river and done river testing. So I know they did. Yeah. The front, they decided to knock out the prairie part that's on the lower part. We tried hard to make that work. And then finally they just said, you got too many mulberries in it. The soil wasn't great. So now they're going to keep the prairie up at the top and we're going to manage that. We will burn that this year. It'll be fun. It's a good time. For sure. Cola, stomach fluid, so on and so forth. Okay. All right. Okay. So I already said those things. Now I have this great book, and it's called. If anybody wants to ever borrow it, "The View from Lazy Point." Okay. I wish that I would have read this book a few years ago because. Was it 4 years ago, maybe? There was an exact AP FRQ question on this very thing that I'm going to read you right now. And I thought I had it marked, and I don't have it marked. Let's just see if I can flip through it. Carl Safina is a great author. Come on, here we go. Let's change this to here. Okay.
Now he's going to look for another spot.
What's that?
Now you're going to look for the other spot.
Yeah. I don't know why that was there, but I have some phone numbers that I have no idea who they are.
Phone.
Yeah, bags. Who knows what that means? All right. Okay, so, and you can go back to this, but I do want to just read this to you now. About half the human-produced carbon dioxide has dissolved into the ocean. We're producing it so fast that it's, quote, backing up near the ocean surface. The North Atlantic is absorbing only half the carbon dioxide it did in the mid-1990s. That will warm the climate faster. By 2080, bleaching will likely hit 80 to 100% of the world's tropical coral reefs every year. That could be the end of them. To outrun that, corals would have to continually adapt their temperature tolerance. But even if corals outran warming, they'd still run into the pH problem, okay? So, and this, man, when I read this, it just like clicked. So stick with me here. In seawater, carbon dioxide triggers a short series of reactions that form carbonic acid and lock up carbonate molecules. Corals, corallines, and other creatures that make skeletons and shells of calcium carbonate need those same carbonate molecules. Chemistry buffs, this is for you. For AP environmental science students, this is for you. When a molecule of carbon dioxide enters the ocean, it soon finds itself attracted to water. These two molecular pairs spawn carbonic acid, that's H2CO3, which then release one hydrogen ion, okay? Oh boy, here we go. Leaving a molecule of bicarbonate behind. That concentration of those hydrogen ions is measured as pH. The more hydrogen ions, the more acid, but the lower the pH. Because increasing hydrogen ions push seawater pH towards the acid end of the scale, this is being called ocean acidification. Compared to before the Industrial Revolution, the upper ocean already has about 30% more, 30%. That's crazy. The problem is that those hydrogen ions easily bind with the carbonate ions. Using up carbonate ions deprives animals like hard corals, clams, snails, and various plankton of building material for making their shells. Okay? So that's the real issue. Carbonate scarcity slows their growth. They become fragile and sometimes fatally deformed. Carbonate concentrations in the upper few hundred feet of the ocean have already declined about 10% compared to seawater just before steam engine times. Okay? Again, I put this on there. You can go back. I'm going to give this to you if you're like, Jabin, when you read, I go to sleep. Okay, it's like when I was a baby. Okay, okay, but get back on that and read that when I send you this PowerPoint. If you're like, I did not understand what just happened, or if you want to hard copy it, you're like, I can't read this. Just ask me. Okay, I'll do anything for you. Okay, so all that's those chemical reactions, right? We're separating those ions, and those ions are powerful, right? Your CO2 loves oxygen, man, or I mean, CO2 loves water, and then when they get together, all hell breaks loose, right? In the ocean, okay? Those hydrogen ions just start like coming off, and then we got trouble, right? Okay, so you all know that matter cannot be created or destroyed. Okay, it's only going to change form. So those are those two. Those were those two laws of thermodynamics. Hopefully, you've all heard of those before. First and second law of thermodynamics, right? So, you know, we've got energy in trees. You know, we heat it up. It just changes form. Okay, most of you hopefully know the difference between inorganic compounds and organic compounds. Okay, inorganic, no carbon, okay, or carbon bound, or do contain carbon, but only carbon bound to elements other than hydrogen. Okay, these are some examples. Okay, inorganic. Okay, so this is inorganic. This is inorganic, right? Okay, compounds that have carbon to carbon or carbon to hydrogen, that's organic. Okay, and so typically think living. Okay, okay, living is typically organic. Don't think like, oh, my mom only eats organic food, right? It's a different kind of organic, right? Y'all with me on this? In college, you might have to take some chemistry, and if you take inorganic, not too bad. If you take organic, it's gonna kill you, unless you just love this stuff and you're like, man, chemistry's my jam. It's like organics. Like I feel like every organic professor is like, I want to make these students like go through lots of pain. I've never heard anyone ever say like, oh, my organic chemistry class is just, it's a breeze, man. It's so easy. But it's cool. I mean, there's a lot of cool stuff in there. Wow, that's cool. All right. Okay. Again, I know I'm going fast. Okay. You're gonna get these slides. Write down the tidbits. Write down the tidbits. My little like maybe stories with that. Okay. All right. There's a calorie and a calorie. There's a big C calorie and a little c calorie. Okay. So there's a food calorie, right? That's the big C. Okay. So when you look at calories on the back of your food stuff, okay, that's what they're looking at. Okay. But small c calorie, okay, that's the amount of energy it takes to heat 1 gram of water 1 degrees C. Okay. We are going to talk about 2 other forms of energy. Okay. The British, or 2 ways to say it. Okay. The British thermal unit, BTU. Have you ever seen like, or heard someone say like, how many BTUs is it? Right? You know, like, no, you never heard that. Okay. And then we're also going to talk about the kilowatt hour. Okay. So the British thermal unit, amount of energy it takes to heat 1 pound of water, 1 degree Fahrenheit. And the kilowatt hour is the amount of energy expended by using 1 kilowatt of electricity for 1 hour. When we look at BTUs and, well, especially with kilowatt hours, okay, there's something on your house that's spinning right now. Okay, that's that meter. That's measuring the kilowatt hours that you're using in your house. That's what they charge you. Okay, so energy, of course, the ability to do work, power, the rate at which work is done. Okay, and some of the stuff you did in your own, cruising through this. Kinetic energy, potential energy, right? So this kind of shows a little bit of both. Okay, which is this right here on this side, all this water. Yeah, potential, and then we're moving it through. That's the kinetic, right? Okay, we're using this to create power because that water is moving through this dam. We'll talk a lot about dams, man. You know, North Manchester is the first. Is a town that has had the first dams removed in the state of Indiana. Now it's becoming really trendy to like remove them all. And the last dam that was just removed was the one at Collimer. Okay, a kid died there, which was crazy. He went old, tried to shoot the dam, never tried to shoot a dam. Okay, like in a kayak or a canoe. Okay, so like, oh yeah, you're not supposed to do that. So this kid was in a kayak, he shot the dam. He got sucked in and couldn't get out. I think he was 17. Yeah.
Yeah, like my uncle at one point did it. And
Yeah.
He, I don't know why, that was fun. And he nearly died. Only thing that saved him is he was like in the Marines, and so his training kind of kicked in, and he remembered you have to swim down to get
Oh yeah.
up,
Yeah.
to get underneath the
Yeah.
water.
So what Jerry Bollinger told me, you guys know Jerry Bollinger? He's a great guy. He said he skipped school once and with his buddy, and they wanted to go fishing on the eel. And there used to be a dam in Liberty Mills, and he and his buddy shot the dam, and both got sucked under, and he thought it was it. And like somehow they both lived. I can't remember if his friend saved him or he saved his friend, but like he said, it was like one of the scariest moments of his life. Try not to shoot the dam. Did you do it? Where'd you do it? Oh, sorry for laughing. You know, they have a fish ladder there now. We'll talk more about the fish ladder. You guys see the fish ladder at Stockdale? You guys know about the fish ladder? It's awesome. We'll talk more about that later. Okay. Energy input, right? There's that potential, the kinetic. Of course, there's going to be waste energy from that. Now, I can't wait to see your homework. And I didn't talk about this until now because I want to see what you did. And the bell's going to ring. So I'll talk about this tomorrow. Thanks for joining me. Hey, could you see everything okay? Okay, great. Thank you. I will try to work on getting a speaker. All right. See you later. Bye.